Good afternoon, ladies and gentlemen. Welcome to TechGig webinars, our endeavor to empower techies. This December, TechGig is conducting webinar series on software project management. Today's session is ninth in the series, and the topic for today is project estimation, techniques, challenges, and best practices. We are delighted to have Mr. Rahul Sudame, Senior Project Manager at Calsoft Private Limited with us. Mr. Rahul is Director of Project Management Institute, Pune, and Senior Manager at Calsoft Private Limited. He has a vast experience of requirement analysis, design, development, proposals and estimations for various projects in domains such as banking, PLM, healthcare, insurance, retail, etc. Mr. Rahul is Certified Scrum Master, Project Management Professional, and ITIL certified. He has comprehensive experience in leading globally distributed teams and managing multiple projects for Offshore Development Center. Gentlemen, this presentation will continue for next 45 minutes and we will take your questions after the presentation. In the meanwhile, you can post your queries through the chat pane available in the webinar software. We will also be asking free questions related to today's topic. Please post your queries on techgig.com only. Exciting gifts will be given to the participant who gives the best answer to the questions. Without further ado, I introduce you to our guest speaker, Mr. Rahul.
Hello. Hello everyone, this is Rahul Sudame and I thank you all for joining today's session. Okay, so we'll start today's session related with the project estimation techniques, challenges and best practices. Estimation is a subject that is near and dear to all of us. You know, we do estimations at every stage always. If you have to go from home to office, we try to estimate how much time it will take. If you have to work on a new house, we estimate how much cost it will take when the house will be completed. When we work on our projects, we need to make sure we have factored in how much resources will be required, how much cost is there for the project, and how much duration is going to be there for the project. And we also have a lot of challenges related with the project day in, day out. We always hear that many of the projects face a lot of challenges and they either go cost overrun or schedule overrun or they don't meet the deadlines. So this is a challenge that all of us are faced with, all of us deal with it, and we hear about it always. So today we'll talk about some of the estimation tools and techniques. We'll talk about the estimation life cycle. We'll talk about what are the characteristics of good estimates and what are the challenges involved in it. And we'll also talk about some of the best practices in software project estimation. So when we talk about project estimation, what we are trying to do is we are trying to quantify the amount or the outcome. So we are trying to not only just have a rough idea, we're trying to quantify the data. And the data that we're trying to quantify here is either we are trying to estimate the activity resources or we are trying to estimate the activity duration, which means the efforts or how much time it is going to take, or we are estimating the cost. And in this particular process, there are multiple people who are involved and there are multiple roles that are played by people in the team in respect of project estimation. So the project manager is of course involved in making sure that the entire process is completed within time, all the right tools or estimation techniques are used, defining the estimation approach. The estimators will provide their inputs and feedback along with the constraints and assumptions and risks. Program management will try to consolidate the estimates not only at the same single project level, but multiple projects and combining their estimates and aggregating at a program level. Senior management or project sponsors will approve the project from internal organization's perspective, and customers will approve or accept the estimates from his endpoint, as well as he will provide all the inputs based on which we will be delivering the estimates, which is basically the requirements or the scope of the project. We need to understand when we talk about estimates that there is always a cone of uncertainty involved, and this particular diagram will explain you this cone of uncertainty. So when we start with initial product definition, when we are at a very high level understanding of the project or a product, the uncertainty about our estimates is significantly high. It could be as high as 160% or as low as 60%, which means if a project which is supposed to run for 20 weeks can actually run for 12 weeks or even up to 32 weeks. So that's a delta that we would see when we are at a very initial stage. As we go along and we have, let's say, requirements clarification or requirement specification is completed, we know what project we are supposed to deliver, what is the scope of the project. Even at that time, we can have 50% off estimates, which means a project which is of 20 weeks can practically range between 17 to 23 weeks. So we always need to understand that as we go along, the cone of uncertainty narrows down and we will have more and more assurance. But what we are trying to do is predict at a very initial stage, and we need to be mindful that there is a cone of uncertainty involved at this stage. Now let's try to understand what is the estimation lifecycle stages. So when we talk about a project estimation, it's not just the creation of estimate phase that we're talking about. There are 4 phases that are involved here. At the start of the project, before even we start the estimation process, we actually start to prepare for the estimate. In this particular phase, we try to gather all the data about the project. We try to have some of the work breakdown structure created. We try to have the estimation approach identified and gather the historical data and all the information based on which we will create the estimates. The next phase is creating actual estimates, wherein the team works together, they sit together, and they try to create estimates, provide them to the customers, and try to get an approval. The next phase, which spans pretty much for the entire project, is managing those estimates, which means not only checking whether we are going as per our estimates, so which means checking whether our plans and actuals are meeting and we are on track with that, but also refining the estimates if the environment has changed, if the scope has changed, if the project characteristics have changed. So this is again a process that spans across the entire project. And we also need to think about the improved estimation process, which means we not only consider the estimations that are given at one time, but how our organization's estimation process is being executed. Are there any opportunities for improving the estimation process as well? So these are the various phases that are involved in the estimation lifecycle. So when we talk about preparing for estimates, we consider various factors. We try to gather all the project documents, which involves the scope that is provided by the customers. If we have requirements clarification happening, then what we can do, we need to have enough details or data collected about the project documents. We need to have experts who are not only experts in the project's technology or domain, but they are also experts in the estimation process. They know how the estimation process works, what are the tools and techniques that are involved, and what approach is most practical approach for this particular project. Then we need to understand different estimation techniques. We also need to understand what are the constraints and assumptions for this specific project that we are working on, and if there are any additional influences that are involved. We also need to have all the historical project information available with us. We need to make sure that we have the project repository available in our organization, which tells us how much data has been the case for the previous projects, which might mean how much efforts were taken by the previous project, how much cost was involved, how much was the resources that were put onto those projects. So we need to have all of this historical information which we will be using for creating our estimation approach. And this particular phase gives us the estimation approach. How are we going to derive our estimates? How are we going to manage our estimates? How are we going to communicate our estimates to our customers? And then how much is the scope for variations in the estimations? Is there a range or is there an agreement where we can have a delta between plan and actual? So we need to have all of this data that we need to communicate to our stakeholders and record them. The next phase is creating the estimates, wherein we use the project estimation approach that we have finalized for a specific project. We use all other estimation information, which means the project requirements document, the scope document, and your risk registers, and all of the information that is available for you. We will have the estimators providing us the specific estimates. We will have the enterprise environmental factors, and we will have organizational process assets as well. If the organization requires a particular process to be followed, let's say an organization is a CMMI or ISO certified, it would have its process requirements. So those also needs to be factored in when we are deriving the estimates. When we are creating the estimates, they can be either of 3 types or 3 categories. We can have analogous estimates, we can have parametric estimates, or we can have bottom-up estimates. And then at the end of it, we have completed estimates, and what was the basis of this estimate also documented for further reference. Now what we do in the next phase is a manage estimates phase. In this manage estimates phase, we have the baseline estimates that were given in the initial stage of the project, and we also get approved changes. We have seen scenarios where the customer requirements keep changing, so there might be change request or enhancement request or a defect request that might be coming up, and we have to deal with them, which means the scope is changing, which means your estimates and the timelines are also changing in line with that. We will have a resource plan, so if the resources are getting added or reduced, or if they have any vacation plans, or if they are not available, or if they leave the project, then also our estimates are going to get impacted. So we need to have that information as well. We will have our work performance information, we will have our organization process assets, and our project estimation approach. We will use that, and we will have that for managing the estimate. So we will periodically track how we are going against our estimates. So what is our plan versus actual, and we'll keep revising our estimates. So the outcome of this, we'll get the updated estimates, we will have the updated forecasts, and updated change request log, and reported something that will communicate to everyone. Another phase which we do not follow sometimes specifically in the organizations, but which is very important phase, is improving the estimation process. It is not only important that we estimate for a specific project and give our estimates to the customers, but we also try to improve our estimation process. So in this particular process, we try to see what were our baseline estimates, what was our approach for estimations, our historical project data, and we also try to look at our forecasts and change versus actual data, stakeholder feedback, customer feedback, and we try to get all of this feedback, and then we try to do an analysis where we actually assess our estimation process. We determine the root causes and the lessons learned. What is working, what is not working in our estimation process, and develop an action plan, and then implement that action plan, share the lessons learned with all the key stakeholders, and make sure that this improvement is happening when you do the estimation next time. So this is again in line with our continuous improvement philosophy, wherein you review your estimation process, your estimation methodology, and assess it objectively and identify the enhancements based on that. So let's look at what are the categories of estimation techniques. So here these are not specific estimation techniques, but the categories of those estimation techniques. The top level estimation technique is usually analogous estimation technique, which is a very high level estimation technique or a top-down estimation technique. We also use parametric techniques, where we use parametric models, mathematical queries, and calculations for estimations. And we also use bottom-up estimations, where we detail down to the work package level. We create this work breakdown structure that we are seeing right now. We have all the project and multiple phases of those projects, the deliverables of those phases, and individual specific work packages, and even to the task level. We create the work breakdown structure, then we identify or estimate at the work breakdown structure, and we roll up to the top for those estimates. So the first category of estimates, which is macro or analogous estimates, it's also called as top-down estimation. And this particular technique we use when we have little information about the project. We're having very high-level information. The scope is very vague, or we have just few liners description of the project. Then we can use this top-down approach. It can also be used when we are and the project that we are working on is very similar to the project that we have used earlier or that we have worked on earlier. So the historical data that we have with us can be related with the project that we are working on. So in that case, we can get a ballpark number or a high-level guesstimate of the project. It is also called as a rough order of magnitude or a conceptual or preliminary estimate. This is not the final estimate. We know this is not with 100% 100% confidence, but this is a ballpark number. This is a guesstimate that we are providing at this stage. And the specific techniques that are underneath this analogous techniques are ratio estimate. In this case, we identify ratio or the distribution amongst various components of your project. So for example, we can say that design cost is 30% of my total cost. Coding cost is usually 30% of my total cost, and testing is 40% of the total cost. What that means is I'm trying to identify some ratio based on which I can do a guesstimate, based on which I can provide or come up with some kind of numbers that can be used as a guideline. The next is a power series, which uses a semi-logarithmic scale and the graphical representation, which is a power quotient and varies depending upon the project. So we can use a semi-logarithmic scale, and based on that we can have the project-specific data clubbed, and we can extrapolate the data to be used as estimates. We also use range-based estimates, which means instead of providing the specific exact estimate number or exact estimate count, we can provide an estimate range. So what I can say is a project that I'm working on can be delivered within 3 to 5 man-months, and the cost will be in the range of 100 to 140,000. So I'm not specifying or quoting a specific number, but I'm providing a range. So this is called as a range-based estimation. Or we can also have a 3-point estimation, wherein we use a statistical probability outcome based on a weighted average. So we also consider the probability as well as we consider the weights attached to the estimates, and then we try to eliminate some of the estimation errors and have some predictable estimates coming out of it. The next category is called as parametric technique. This uses various statistical relationship between the historical data and other variables to get the estimates. So it is using activity duration and cost. It is quantitatively determined by multiplying the quantity of the work by the historical cost and the duration. So an example of this, let's say a person or a laborer takes 5 hours to dig a 3 feet deep well that is 10 feet long. So we have this historical data available with us. And now a same resource is going to do the same digging work, but now it is 20 feet well. So in this case, we know that other parameters are not changing. So in this case, the amount will be double, which is 10 hours, so which is in proportion to the data that we have. So if we have this kind of comparison available, then we can use parametric techniques and come up with some kind of approximate data that can be projected as estimates. We can also use micro or bottom-up techniques. The prerequisite for this particular technique is you need to have a work breakdown structure. You need to have the detailed task level breakdown of the bigger module, the sub-modules, the work packages and tasks. And you will estimate at the task level at the lowest level, then you will sum up at the work package level, and then in the same manner you can keep on summing up at the parent level. So this is a technique that is widely used when you can decompose your systems into minute level tasks, and then you can use it basically to roll up the tasks and get your top level estimates. So let's look at what are the estimation techniques that are available. There are multiple estimation techniques that are used by different projects in different organizations. Some of the common that are listed over here, and we'll try to go through some of these estimation techniques. There are pure expert judgment and historical data. We have wideband Delphi, source line of code, function point, use case point, story point, Monte Carlo, COCOMO model, test case point, or function test points. So these are the various tools and techniques, and in reality you would see many other techniques are also used for deriving the estimates. So we'll go through some of these techniques by now. So the first one is pure expert judgment. So in this case, a person who might be a technical lead or a project manager or a subject matter expert, he would go through the requirements, he will try to understand the requirement, and he will come up with his guesstimate. So the person will say, okay, I have worked on this particular login module earlier, and based on my experience, the same login module developed for this particular project will take 1 month. So this is based on the feedback of the expert. And you might see practically that this kind of thing this may not have a statistical confirmation, but this is very widely used. You know, we ask the experts for the estimate, and whatever number is provided by them, that is the number that gets quoted as an estimate. So this is one technique used, which is just pure based on the expert opinion. The next technique is using historical data. So most of the organizations would have the project historical data available with them. So the projects that we have delivered earlier, we would know how much cost was involved for those particular projects, how much resources were working on those projects, and how much was the duration of that project, and in which domain or what kind of work that we did in that kind of project. So we can use that information. We can try to have an analogy with the new project that we are working on or that we are trying to estimate. And if we see an analogy with the existing projects, then based on that we will try to extrapolate and get the data, which we can project as an estimate for this particular project. So estimation by analogy is a very common scenario where we try to see if the same or similar domain application project has been done by us and use that data and refer that for the estimating the current project. The next similar method is proxy-based estimating, which is based on an idea that if the person is developing a component which is very similar to the one that he has developed previously, then it will take approximately the same effort that it took in the past. So what we are trying to see is, okay, how much work was required for the similar work in the past, and as a matter of guesstimate, we can say, okay, it will take approximately the same duration. So it's based on a formula or a linear regression that is used to calculate the estimate for each task from the history. The next method is a wildband Delphi method. So this particular process is a very repeatable process. It's an estimation process which have multiple rounds of iterations, and it tries to get a consensus. It tries to arrive at a data point which we can use for estimations. The way this particular process works is, we start with round 1 and we ask all the team members to read the requirement specification and come up with their estimates, and then all of them share their estimates. As you can see in the bottom graph at the bottommost line, round 1, the estimates might vary to a significant range. You know, some of the team members say, okay, this is very easy task, looks to me, and can be done fairly quickly. Some of the other team members might say that this is very complex and this would require significant efforts to be done for that particular project. In that case, we ask the team members to share their views, to share their opinion, and then we ask, why do they think this is taking more time or less time, or what was the basis of their estimates. Now once we hear that, then the team members might know, okay, the team member who gave the higher estimate really has a valid point, and I also needs to consider that. I also need to factor in. And then the team again re-estimates. So then the range will reduce. And then in the similar manner, the team will arrive at either a number or at a range which is acceptable to everyone. So this is a wideband Delphi method where the team provides the feedback and collectively they try to arrive at a range which will be acceptable to entire team. The next method, which is again a very frequent method seen in software project estimations, is estimating the source line of code. So basically a unit to the line of code of a software program. How much line of code will be required to be written for this particular program. So in this case, we might have to divide the problem into modules and then submodules and even to a lower level until it reaches to a level where we can estimate it. We might have some kind of algorithms written or flowcharts written or a control flow of the project derived, and based on that we try to understand how much of the line of code is going to get involved. We can also use the historical data, and we can also use the industry data, that if you're using a program or if you're writing an assembly language program, then for the single for loop statement, how much lines you will have to write in assembly. For a same statement, for a same logic, how much a line of code will have to be written in C, C++, or Java, or any of the other languages. So what we are trying to do is identify how much line of code will have to be written for this particular project. There are two major types of SLOC, the software line of code. One is physical line of code, where we count each and every line of the source code, or it can be a logical line of code, wherein we identify the executable statements. That is, we do not factor in the comments, or we do not factor in the blank lines and things like that. So KLOC is one of the very common method that has been used historically for estimating the software project duration or software project estimates. The next is the function point based estimation. So function point based estimations are basically from the user's point of view. It is based on the function count and based on the user request and what the user receives in return. So what is that user is asking from the system and what is that user is getting from the system. So it has 5 key components. It has external inputs, it has external outputs and external inquiries that are coming to the system, and internal logical files that are used for the internal processing, and external interface files. So it factors in all of this data, and then it comes up with the function points. And you can have unfiltered function points, and then you can normalize this data, and then you can get more structured or filtered function points. So this is a very commonly used method in software project estimations. The next one is the use case point estimations. So this particular estimation method is based on use case modeling or UML modeling, wherein you create use cases for various scenarios and then you estimate based on the various factors of those use cases. So how much is complex that use case is? Is it a medium complex, low complex, or a high complex use case? Are there any other factors that are involved with the use case? What is the technical complexity factor? What is the environment complexity factor? What is the unadjusted use case points that are involved in this particular use case? And what is the productivity factor in your organization or for that department or for that team? So we use all of this data and then we try to come up with the use case points for a particular project. So we might have, let's say, 100 use cases, and then we'll try to categorize them whether they are simple, average, or complex, and then apply a weight to them. And then based on that, we try to come up with the use case points for a particular project and then estimate based on the use case points. The next method that is used in agile software development or agile programming is called as story points. So story point is a relative measure of complexity instead of an effort or instead of an absolute number of hours. So what we are trying to give is a relative sizing of the project. And this is used in agile estimation and planning. So what we're trying to do is, if I start with the story 1, a user story 1. User story is a piece of functionality that I'm working on. I start with the user story 1 and I say that this is a medium complex user story. So I give it a story point of 3. Then I start with the next user story, and that is double complex of the story that I was previously reviewing. Then the story points will be twice as complex or twice the number as my previous user story. So this will have double the story points. So based on this analogy, we try to identify the story points for a project. There are similar analogies available related with that, which is t-shirt sizes, which means if a person that I'm looking at is actually having a t-shirt size of medium, a medium-sized t-shirt fits for him, then if I see a next person who is much thin than him, then what is the t-shirt size that he would require? If I'm looking at a person who is much fat, then what is the t-shirt size that he would require? So based on that, I try to arrive at a t-shirt size. Or similar analogies for dog points. So if we start with a particular dog breed, and if we look at a compare with next dog breed, is it twice tall, lesser tall? Based on that, we arrive at dog points. We also use zoo points or ideal days are the other terminologies that can be seen. Ideal days is the number of days that the story would take, assuming that there is no other work that is involved. So we are not counting the time that we spend on non-project related activities, which might include anything from your emails or meetings or any of the other discussions which are not involved. And there are two processes that are used in the agile environment. One is the Scrum method, which calls it as a planning poker, and in extreme programming, the process is called as a planning game. So in planning poker, we get cards of different story points mentioned in that. All the team members work together and they understand the requirement, they clarify the requirement, And after that, all of them show their story point cards together. And the team reviews the range of those cards. And the people who are having the lowest or the highest story points, they will explain their rationale. And the team will again reevaluate based on the discussion that has just happened. So based on that, the team will try to arrive at a story point. In planning game, each story which is written on index cards is given to the estimator, and then estimators will have 1 or 2 or 3 weeks estimates added to that. And this particular process is repeated continuously throughout the project. So the major characteristics of story points are they are provided at the start of the project, but the agile nature of the project is in iterative, incremental, and that's how we keep on iterating the projects as well. The story points might get added or reduced, they might change. The another estimation technique is called as 3-point estimating or PERT technique. So which uses 3 separate values for estimation, and they are derived from optimistic, pessimistic, and most likely values. So we try to get someone's opinion. Okay, what is your opinion about having this project completed? What is it an optimistic estimation, or what will be the range? Or if I ask you, what is the most pessimistic number that will you give for completing this particular task or this particular story or a requirement? And then we get that data, and then we try to arrive at the statistical probability outcome and a weighted average. And then we come out with the estimates. So this is a technique that we can come out wherein we ensure that the over-optimistic or over-pessimistic estimations are factored in or are normalized in a logical manner. There are many other techniques also involved in the estimation process, and those techniques we'll just list or we'll go through some of them quickly. One is Monte Carlo technique, which is based on generation of multiple trials to determine the expected value. So we'll have multiple trials, and then we try to arrive at the values for the variable that we're discussing on. The next one is the Parkinson law, and this law says that work will anyway expand to fill the time available. So instead of estimation on absolute number of hours, we'll say that the cost will be determined by the available resources. So if the software has to be delivered in 12 months and 5 people are available, then we say it is 60 man-months project. The next one is test case point, where we try to identify the estimates of the testing projects using test case as an input. So we have use cases. Based on use cases, we derive the test cases, and we try to estimate the test case points, and we apply the normalization factors, and then we have the filtered test case points available for estimation. Another technique which is practically used is pricing to win, so which is cost estimation technique. So price or quote as per what the client is prepared to pay, whatever is the bid amount and whatever is the quotation amount. So based on that, we try to bid and get the project. There is a detailed, extensive cost estimation model, which is a COCOMO model, which is a hierarchy of software cost estimation models. It involves the basic COCOMO model, intermediate model, and detailed model. So it is trying to estimate the efforts and the development time based on the coefficients. And the coefficients and parameters are different in different models, and the details are included in the specific models. And based on this data and based on the line of code projections, we try to arrive at the cost estimations of the project. So we have so many estimation models, so much ways in which we can come up with estimates. So what are the estimation methods that we should be using? If you are estimating a new project, what method or what technique should you use? So there are some guidelines that are mentioned over here. So if your project requires some strategic decision making, you're not trying to do each and every minute requirement level commitment yet, but some ballpark number is required for strategic decision making, then you can use top-down techniques. If the cost and time is important, if it's critical and it's going to be measured against, then you should be using bottom-up estimations. If there is a high uncertainty of the project, then it's recommended that you use top-down estimates or guesstimates for those projects. If the project is internal or small, then having entire estimation cycle applied probably would be an overhead. So in that case, you can have top-down estimates. If it's a fixed price project, it's always recommended to have the bottom-up estimates. You go to the lowest level, you identify each and every task, You estimate the task and roll up at the higher level. If the customer wants all the details, then also you will have to go to the task level and provide the estimates based on the facts. So you're not talking based on just some expert's opinion or someone's feelings. You are talking with the base of data and with the basis of facts. If the scope is unstable, if the scope is changing very frequently, then it's recommended that we use top-down models. So these are some of the guidelines that we can use for identifying the estimation techniques. And practically what we do in the industries is we use a combination of multiple techniques so that more predictable estimates can be generated. Now we look at what is the estimation management cycle and how the estimates typically work. So what we do is we prepare estimates and we generate the estimate baseline, which is communicated to everyone. Then we apply actuals to it once we start working on the project. We get time entries, we get resource expenditures and all the details. And based on these when we apply actuals, we try to do a comparison of actual versus estimated. And we have project management systems, we have earned value management, and we have several other tools for that. Then if required, if the environment is changing, if the scope is changing, or the project environment is changing, then we re-estimate the project. And the cycle continues throughout the project. And then we have end of the project or end of the phase. Then we document the lessons learned and we discuss how we can improve the estimation process. One of the factors we need to make sure while we are doing the estimations is we need to have very strong matrices for tracking our estimations. We cannot have just estimations given and not tracked thereafter at all. We need to continuously make sure that whatever estimates we have given, either phase-wise, module-wise, or requirements or story-wise, we are tracking against them. We are making sure that our planned and actuals is matching. One of the tools that can be used for this particular tracking is earned value management, which is a project management technique which can be used for measuring planned versus actual. In agile environment, the burn down chart, the release burn down chart, or a project burn down chart, or a sprint burn down chart is used to see if the project is on track or not. Are we going as per our plans or not? But this kind of metrics is definitely required to have in the projects. Now let's look at some of the challenges. What are the challenges that we deal with or that we face day in, day out in our estimation processes, specifically related to the estimations? The biggest challenge is the estimates are treated as actuals and they are treated as commitments. So what we are trying to actually come up with is a guesstimate. We are trying to say that this is what is the estimate based on our understanding as of now. As we talk, this is what we think is going to be the project's schedule or resources or cost. But things do change, the environment do change, and that's how the project estimates are also supposed to change. But that's not what happens most of the times. They're taken for granted and everything is planned based on that estimates, considering them as actuals. The next challenge is estimates don't change when the environment changes. The scope has changed, the requirement has changed, or your team members' composition has changed. But we don't change the estimates. We don't communicate this change of estimates to the customers. So the date still remains the same. The project cost still remains the same. The next one is if you have the change in requirements or technology, or you're not having enough scope clarity at the time of estimation. When you started the estimation, you were not having enough details at all. So the basis itself wasn't strong. So then also you're going to have a lot of challenges with managing or working with those estimates. There could be approved change requests coming in, due to which you will have to re-estimate and you will have to work on your estimation process again. There could be a scenario where you are not having enough data or enough experts who are familiar with the estimation process and who can give you a guaranteed estimate or something that a better predictable estimate that can be used. You might also have external dependency on external vendor, and estimating based on that external dependency can be a challenge. You are assuming something that you will get something connected by the external vendor in this time frame, but the actual could be really different. So in this case, your estimates can significantly go off. And another challenges you might have is estimating the non-functional requirement, something of like what is the performance of the project, or what is the user experience of the project, or what will be the usability aspect or quality aspect of the project. So tracking or estimating the non-functional requirements can be a challenge, or estimating the POC, proof of concept kind of projects, prototypes is also a challenge. So some of the inputs that we can get from the agile project estimation and planning for the challenges that we discussed, we can look at that. So the agile estimation and planning process is fundamentally based on a fact, or fundamentally based on the premise that the estimation process is done by the team and the estimates are owned by the team. So the estimates are not dictated by project managers or by team leads. The team members, all of them participate in the estimation process. All of them share their views and why they think it's a high estimate or low estimate, and they agree with that estimate. So there is a buy-in, there's the team buy-in involved in the estimation process. And the team estimations can change periodically, they'll be revised periodically and updated periodically. So this is a process that definitely helps on handling some of the issues or challenges that we discussed earlier. The scheduling in Scrum is typically based on something called as velocity, which is a measure of how much work can be done in a given amount of time. So we use this and we try to rectify our estimation errors over a period of time. Now let's look at what are the characteristics of good estimates. When we try to build good estimates, what should be the things that need to be factored in for those estimates? So some of the characteristics of good estimates are, we need to have a clear identification of tasks. What is in scope for estimation, what is not in scope for estimation? What are the rules and what are the assumptions, what are the challenges? All of that needs to be very clearly understood by the team that is doing the estimations. The next guideline is broad participation in preparing the estimates. It is very important that the team members who will be working on it, as well as the project managers or team leads or architects, are involved, so that you're covering all the different aspects and you're trying to make sure that it is accurate, complete, and reliable. You also need to have valid data for the estimates, and you can have numerous organizational sources that you can use for that. But if you have valid data that you can depend on, that will always come handy for you for estimating the next project. We also need to have the standardized structure for the estimate. We need to have a good work breakdown structure, which will have decomposition of the requirements, and that will help us getting more clarity of what we are trying to do and what we are trying to estimate. The provisioning of program uncertainties. We definitely need to factor in what is not known, and we need to have the mitigation plans for any of the risks or uncertainties. We also need to recognize the inflation. If we are estimating based on the current cost, current resources, availability, and current the time plan, it may not work. We need to understand if it's a 2 years, 3 years project, then we have to factor in inflation and all the other economic factors as well. We need to recognize the excluded cost. We need to be very clear what is included in the cost and what is excluded in the cost, what is part of the estimate and what is out of the scope for the estimates. And we need to revise the estimates for significant project changes. Whenever the project environment changes, we need to make sure that we are revising our estimates and then modifying and publishing those estimates. Now, we also can look at what is the different tools and techniques that we looked at and what is their applicability across different industry verticals. So there are different standards or estimation techniques, and their applicability in different industry segments is different. For example, if you take an example of story points, story point, which is a parametric technique, is very widely referred to in information systems in IT environment. But the historical data is very widely used, practically used in almost all the industry segments. So similarly, we can understand what is the applicability of the estimation technique that we are trying to use in our projects. There are some inputs for how to communicate the estimates, how we should explain the estimates to our customers, and there could be multiple ways of doing that. And that of course depends on what kind of environment you work on. Is it a product-based environment or services-based environment or a fixed price or time and material based? But based on that, you can have the estimates communicated in different ways. You can have plus minus qualifiers where you will say that, okay, this project is 6 months plus or minus 1 month, or it can be in a range of estimates. It is 6 to 8 months of duration, or it can be attached with the risk quantification. You can say there will be 2 months added or 2 months delay will happen if the hiring is delayed. So you attach risks with the estimates. You can have the cases like the best case, worst case, planned or current cases estimate. So you can present that information to make it more granular. You can have course dates where you will say, okay, this particular product will be delivered somewhere in Q3 2012. You can have confidence factors included, which is again practically used in many scenarios where I'll say that, okay, I'm 10% confident that it will be delivered on 1st of April, but I'm 50% confident that it will be delivered on 1st of June. And another aspect which is called a student syndrome, which means procrastination unless the last minute, which means prepare when the exams are coming up. So defer the estimations actually until they are required. So if you see in Agile, we provide the high level estimates initially, and we provide the low level or the task level estimates only when the specific sprint or the duration of time is going to start. So we defer it until that. Now let's go through some of the best practices or guidelines or inputs on how we can build good estimates, what we can do for the estimation techniques. So what practically we can use is we can develop both the top-down and bottom-up estimates. So if the project is a high-risk estimate, high-risk project, and it requires very detailed estimates or the estimates that we can rely on, then we can use a combination of top-down and bottom-up estimates. Or we can have multiple estimation techniques that can be used to get more coarse-grained or more detailed estimates as required. So for example, initially when we have the use cases developed, we can have the use case based estimation at a very high level. And when we go to the design level, we know what are the inputs and outputs and all the data of the system. At that time, we can have the function point based estimates. So we can have a combination of that. Another guideline is to get the estimates consensus from the team instead of imposing the estimations. And this particular guideline have seemed to be working very well in the Agile environment, where the team members who are actually going to develop, if they estimate, then that comes up with a lot of buy-in along with it. Another guideline is we need to have progressive elaboration of estimates as the requirements elaborate. If the requirements are getting changed, if the requirements are getting modified, our estimates also need to modify. And whenever the environment changes, there are significant changes in the project environment, we need to have the estimates also revised in line with that. We can use normalized historical data. That always comes handy as a reference for future expectations or for using the estimates. We also need to do a major work on managing the stakeholder expectations, because if your boss comes and tells you that this project has to be delivered in next 3 months with this particular scope, then what you really need is expectations management and not estimation management. So you also need to ensure that you're doing the proper project stakeholder expectations management. We can use empirical methods, we can use automated tools and templates for the software cost and effort estimations, and practically many organizations would have their own Excel sheets or spreadsheets or software project management tools using which they will derive the estimates. Now another important fact we need to consider is we need to quantify the impact of the risk in the estimates. Usually we do risk management where we just have the risks mentioned as a text and they don't get converted or they don't get factored in our estimates. But if we have high impact or high risk, then we need to have the buffer or padding also adjusted in line with your risks of the project or uncertainty of the project. If it's a high uncertainty, you would like to have high padding or high buffer adjusted accordingly. One more aspect is we also need to make sure that the process aspect is considered, which means the design time, the test-driven development or behavior-driven development time, the code reviews, documentation, performance work, your project audit requirements, all of them are factored in the estimates. You're not just covering your code time or your core implementation time, but you're considering all the other aspects as well. And another key important guideline is inspect and adapt. Continuously try to see how the process is working for you. Are you in line with what you projected or what your estimates were? Is estimates and actuals managing? And then keep on evaluating the things in line with that. So this is what I wanted to share with all of you, some of the inputs and best practices related with estimates. Now we will take a break and we'll see the queries asked by some of our team members. Okay, one of the question asked is, can you give an example of top-down method and bottom-up method? The question is asked by Ramesh Rajamani. So one of the example of top-down estimates is what we refer to as the PERT estimates or ratio-based estimates, where we say that okay, 30% time is given for the design activities, and 60% or another 30% is required for our coding activities. So this is a top-down estimates where we arrive at. And the bottom-up estimation is where we create the detailed work breakdown structure, and then we estimate at each individual item level, and then we try to come up with the estimates which are rolled up at higher level. Okay, the next question is, can you tell few examples of risks related to estimation that we can include in the risk management plan? Okay, I'll tell you a few examples. If let's say you are working on a software development project and you are dependent on an external environment, let's say you are working on a project which is based on a cloud environment, and the procurement part is not yet finalized. You do not have all the procurement related with the project completed yet. In that case, what you will practically do is you will make sure that risks are attached to your estimates. So what you will say is, if I get all the estimates right away, if I have to give the estimates right away, I will consider the uncertainties or consider the risks, which are basically the procurement not being finalized in time, which is a risk. If this is a risk, then my project estimates will probably be 10% off, or it might introduce 1 month's additional delay to what I have estimated. Okay, the next question asked by Kamal Gupta is, does program management come into picture when we are working on single project that is not part of the program? So usually in project management methodology, we work on a single individual project, or when we can work on a program, the program might mean multiple projects clubbed together, but they are not all heterogeneous projects that are clubbed together. The projects that are clubbed together that are related to each other. So they all are related with each other. So in that perspective, what typically happens is we estimate at a project level and then we roll up at the program level. So because the customer might have one entire program which would have multiple phases, and we are estimating for the phase 1, and the project for that is related with the phase 1, we will estimate for that. But there might also be an expectation to provide estimates for the next phases, next projects which are part of the same program. So in that case, you may not have enough details. So in such a case, you will use top-down estimation models, or with a confidence factor attached to it, that okay, we will have the next phases completed by end of the year with, let's say, 40% probability or 60% probability attached to that. Okay, the next question asked by Mr. John is, how do you bring the level of experience of the team, both on the technology and the domain, into estimation, as these two play a critical role in efforts? And that's absolutely correct. So that's why the recommendation is, if the estimations are done by the team members, and that factors in the experience level of the team members, experience in technology as well as experience in the domain, then your estimates are going to be more practical. Let's say if a team lead says that this particular login module can be developed in 1 week, and that is, let's say we are thinking of developing it in Java, but I'm having a team member who is a fresher and he's not well acquainted with the technology yet, he will take some learning time. So if he is going to do that estimation, he will say that, okay, I might take 2 weeks to develop this same component. So that definitely has to be factored in. And in case of agile environment, it leaves it, or it basically boils it down to the team members level, where they provide estimates based on their experience and their comfort level, and including the learning and all other aspects included or involved. And since we are talking about this, one more comment related with that is, it is not only just related with the experience in the technology or in the domain, but we also need to consider the capacity of the individuals, because we might be estimating just based on the technical aspect of it, but we also need to factor in the capacity of the team members, the availability of the team member for the project. If the person is available only for 10% of the project, then we will have to make sure that that particular availability is factored in when we are trying to estimate. Okay, the next example is a test case point on a test case point estimate. So what we typically do is we create the use cases. Based on the use cases, we create the test cases. For the test cases, we can cover them into 3 areas. Basically, the complexity of the test cases, whether the test case is high complex or medium complex or low complex. And based on that, we arrive at a number. Then we try to use multiple weighted factors so that the estimates that we are coming up with are practical estimates, and that factors in the performance environment factors as well as the project complexity factors in line with that. And then based on that, we try to arrive at a test case point for a particular project. Okay, the next question by Bhuvana V is it a good practice to always include risk management plan with estimates? Is it a norm and a standard? So this is definitely a good practice, and this is definitely recommended. Unfortunately, not all projects do that, and that's why it gets identified as that whatever you're projecting as estimates is an absolute number, which in fact it is not. What is happening is we are saying that these particular estimates are based on certain assumptions, and each and every assumption is a risk. We need to understand that all the assumptions of a project are implicitly are risks for the project. If the assumption is invalidated, then that is a risk for the project. So all our assumptions should be clearly stated, all our risks should be clearly stated along with the estimate. So your risk management plan should definitely accompany your estimates. And another better approach is you not only have the risk management plan, you not only just have the textual representation of the project or the quantification of the risk, but let's say you have considered the risk, probability, and severity. So you have a quantified number of the risk. Now you use that to convert into estimates or the extra efforts as well. So which means if a project probability and severity is very high, then I will need to reserve an extra time as a contingency for managing that risk. So that either becomes a part of my estimate or that gets added to my estimates as contingency reserve or as buffer or padding of the project. So it is always in line with your risk scenario or risk profile of the project. Okay, the next question by Mr. Santosh is software line of code, source line of code, can be used only at the end of the coding phase? And this is a very interesting question, because how will you project how much line of code I'll be writing at the start of the project? And that's precisely a major drawback that many of the people thought about the line of code based estimation. But there are several techniques or guidelines that are available about projecting how much line of code will be required for a particular piece. So what we typically do is we consider an entire project. Let's say I'm trying to write a login module. What I will do is I will split that into all the lowest possible modules or sub-modules, and then I can have an algorithm written for that module. And that algorithm, based on that algorithm, I can count how many are the control statements, the if statements, else statements, or loop statements, and things like that. And then based on that, I'll see how much statements will be required. And it will also be complemented with the programming language that I'm using. If I'm using the same project or the same functionality, if I have to develop in another programming language, then of course the line of code that will be required is going to be significantly different. So it always needs to go with what is the software development methodology or the project development methodology that you are using. And then based on that, you can have algorithms, and then you can project your line of code. Now there is also some historical data or statistical data that is available across the industry. So you will know what is, let's say you are writing a small program, how much will be the line of code using assembly language, how much will be the line of code using C language, C++, or Java language for the same functionality. So you have some industry data as well available, which you can use to refer in your project. Okay, the next question is, once the baseline is done and if change request is received which requires a change in baseline, how this can be handled in estimation. So in typically some of the organizations, what they do is whenever a change request is received, there is a formal change request approval process that is followed. Now this is typically followed in case of the SDLC model of the software projects. This may not be applicable in the agile environment where the change requests are welcomed and they are considered part and parcel of the entire process itself. But if, let's say, we are following an SDLC method, then whenever we receive a change request, the typical change request goes through an approval process where the people who are trying to implement will provide the estimate about what will be the cost added or what will be the extra effort that will be added for implementing the change that is requested in the change request. So let's say I receive a change request, I'll say that this particular change request will take 2 additional weeks. And if that means I'll have to increase my project deadline or change my release date, or if that means customer is willing to negotiate on some of the existing project requirements to be taken out, then that decision will have to be taken by by a body called a change control board. So change control board will get your estimations for the change request, and then based on that, further decisions will be taken. Okay, the next question is the estimation challenge we mentioned is something that we that is practically seen in the if the project cost goes down, then the customer is communicated about. If the cost goes down, then the reduction in cost is not communicated to the customers. But if the cost goes up, then that is communicated or that is highlighted or escalated to the customers. Now, this particular scenario requires interaction or a constant interaction with the customers, and it is very important that you build a trustworthy environment or relationship with your customers. So in many practical scenarios or many big environments, you will see that customers not only just ask for the estimates that are given to them as an end estimate, but they also want to understand the estimation process, or they want to be involved in the estimation process in some cases. So they are not only looking at the final 3 months date that you have given to them, But what practically happens in some of the cases is the team provides them the high-level requirements design, the low-level requirements understanding document, the high-level and the low-level design document, and also the drill-down design document to a level where the individual classes are added or methods are identified, and how much of Java work will be involved, or how much of the server side work will be involved, how much of client side work will be involved, how much of middleware work will be involved. So a detailed breakdown of the lowest possible unit is done, and based on that the estimates are generated. So all the estimates that are provided based on such kind of data is, and this kind of estimate along with the risk profile of the project, and this is made totally transparent to the customer. So customer is not only aware that whatever I am getting is not just a ballpark number, but this is the basis that is used for that estimation. So this kind of communication with the customer, this kind of transparency with the customer has really been observed, that it helps to build the relationship, the trustworthy relationship with the customer, as well as to mitigate some of the risks. So if things are going off track, then the customer is also aware of that, and we're not trying to handle that in-house. Okay, the next question is how the capacity, available hours, and project estimation is linked. Is it in top-down or bottom-up? So I'll give you an example of how the estimation is practically done in agile environment. So what we do is we start with story points, which we can relate it to top-down approach, wherein we say that this particular requirement is a story point of 13. So that's a very high-level sizing that we have done for that particular requirement. Now we go next when we start a sprint, which is 1 week duration of a project cycle. Then what we try to do is we try to actually go and create a work breakdown structure. So we take a requirement, we identify all the tasks of that requirement, we estimate all the number of hours that are required for that requirement. So we know that there are 4 requirements and these are the tasks and this much number of hours work is required for that requirement. Along with that, we also factor in the capacity of the team members for that particular sprint. So for that particular sprint, I have 11 team members in my team, but 3 of them are going to be on vacation for 2 days. So that means I cannot count in their capacity for that sprint. So I exclude that from the capacity. There could be other company meetings happening, or there could be other planned holidays, or there could be many other things which are capacity exceptions, which I will have to eliminate. And then what remains is the actual capacity of the team. And then what I do is I see, okay, I have an estimate of these many number of hours for these tasks. So based on the availability, how much work can I practically do in this particular sprint? So this way the capacity and the estimation gets linked. But this is also linked with the estimations and the scheduling, because we use the capacity data while we are trying to do the scheduling of the project. Okay, the next question is by Deepak is, are there any best practices for keeping buffer in the estimates for uncertain work? Example, is it good idea to decrease the capacity itself or the individual tasks? Should you have buffer built in, or should we have a risk factor against the overall estimate? In general, the recommendation is we should not try to do a padding at individual work item level, because then the project estimates get floated to a significant major extent. So the recommendation is you should have your task level estimations, and you can apply the risk factor, and based on the risk factor you can have an extra buffer that gets added to the project or a padding that gets added to the project. But the usual recommendation is not to add the padding at each and every task level, because in that case it might be a overly bloated number which may not be realistic. Okay, the next question is what are the methodologies used to get good quality feedback for project estimates from team members if needed? This is asked by Rajan. So it is always recommended that we don't just ask for a feedback from team members on the estimates, but we actually have the team members involved in the estimation process itself. So what we can do is the team members will be involved, and some of the techniques that we discussed in this presentation, what you will see is the team members not only just receive the estimates and then work on their projects based on those estimates, but they are also part of this estimation process. And this is always the better approach. So in this case, what happens is team members try to understand the requirement, they identify the approach or the estimation technique that we are trying to use, and based on that they will provide their estimates. And if there are differences of opinion amongst different team members, then we try to understand the rationale behind those differences. And in some cases those differences might be legitimate, and the feedback shared by the team members might actually be relevant, and the other team members would like to factor that in while they are doing their estimation. So this is the recommended practice, wherein we involve the team members and we get them participate in the estimation process. We understand the difference of opinion of the team members, and based on that the team comes up with the revised or the estimates that are agreeable to everyone. Okay, the next question by Mr. Muralidharan is, while estimating, what weightage should be provided for the environment? What weightage should be provided for the environmental factors like a strike or a heavy rain or others? Or these factors should be considered as a risk factor? So as we discussed earlier, it is recommended that we don't factor, or we don't include or consider the risks in the estimates, or we don't consider them for bloating the estimates of the individual work items. The recommended item is we complete our estimation process and we add contingency reserves on top of it. So what we can practically do is we make sure that we have our estimations, we have our risks identified, and then we quantify those risks. So I'll say that, okay, if my probability is 3 and severity is true, then the risk count is 3 into 2, which is 10. If this is the count, which is significantly high, then the model that I try to develop is I will have, let's say, 20 hours reserved for contingency management. If it is low, then probably I'll not have to have this much of contingency added. But if the risk is high, I will definitely would like to have additional buffer that is factored in. So either I can add buffer on top of the entire estimates, or I can identify this number of hours that will be required for mitigating the risks. And the numbers or the hours or the work that is required to mitigate the risk, you can include that as a part of your risk management plan. And that efforts get calculated in your estimates. So what will practically happen is I will have my estimates, core estimates, I will have risk management process, and then based on the risk management process and the risk profile, I will have extra buffer added, as well as the risk mitigation number of hours or risk mitigation efforts hours added to my estimate. And this is very transparent to our customers. So when the customers know that this is the risk and this is the mitigation hours that I'm considering for my estimates, then he also knows that if the risk actually takes place, then I will be utilizing them. But if the risk does not happen, then this is my advantage. It's an advantage to the customer because that time will not be utilized. and that efforts will not be used in case the risk does not happen. Okay, I think we have covered some of the queries by the team members. If you have any additional queries, I'll request you to post on the TechGig site, and we'll certainly try to provide my inputs, as well as all the practitioners can share their inputs as well. I hope this session was helpful to all of you. So I thank you all of you for participating in this session, and I hope this adds some value to all of you. So thank you for participating in, and thank you for your time.
Thanks, Mr. Rahul, for your informative session on project estimation, techniques, challenges, and best practices. It was indeed an enlightening session. I would also like to thank our participants for their support in making this webinar a huge success. The recording of this webinar will be available on techgig.com by tomorrow. We are also delighted to announce that TechGig webinars are now approved by PMI. All attendees can claim PDUs for attending these webinar sessions on techgig.com. We will send you email for giving more information on this. The next session in the webinar series is happening tomorrow, that is 21st December at 3 p.m. Topic for tomorrow's webinar is Code Walkthrough, Large Data Set Processing with Hadoop and MapReduce. We will be having Mr. Vaibhav Jain, Research and Development Engineer at Times Business Solutions Limited, as our guest speaker. So see you all tomorrow at 3 p.m. Have a nice day. Thank you.